In the following series of videos, we will be solving problems about Chapter 9. We will be tackling the following points: how to construct a confidence interval when estimating a mean of a population, in both cases where the standard deviation of the population is known or where it is unknown, how to construct a confidence interval for a proportion. Lastly, we will learn how to determine the sample size in the case of a mean or a proportion. We will be using in each case the corresponding formula, and we will be solving from worksheet 3. To cover the first part, let us solve problem 2 from worksheet 3. A manager of a restaurant wants to know the average spending of his customers on meal. He chooses a sample of 115 customers, that is our n. The mean is 9.74, that is x bar, and the standard deviation of the population is 2.93. To put things in perspective, our population is all the customers of the restaurant, and we took a sample of 115 customers from the population. This is n. The x bar of the sample is 9.74. What we want to estimate is the average spending of all the population, which is mu. When we say estimate, it means that we are not sure of our answer. To estimate mu, we have two ways. We either use a point estimate, not asked in this question, but we will solve it nonetheless, or we use a confidence interval estimate. The point estimate for mu is exactly x bar itself. If we want to estimate the population mean using one single value, it would be best to use 9.74. The second way is to construct the confidence interval for mu, a range of values which mu would fall in. We will use the following formula to find z. We draw a normal curve with two tails. The error is divided into 2.5 on each tail. To get the area from the mean to z, we will subtract 2.5 from 50%, and we get 47.5%. We go to Z table and search for 0.475. We get a Z value of 1.96. Substituting this in the formula will lead to a margin of error of $0.54. So our sample mean is $9.74. We add to that 0.54 and we subtract from that 0.54 to get the confidence interval. So our mu is between 9.2 and 10.28. We have two ways to interpret this result. We either say that we are 95% sure that the true mean of the population falls between these two values, or about 95% of similarly constructed interval would include the population mean.